Okay, then again, very important theorem is cyclic quadrature. Regarding cyclic quadrature, we have another very important theorem. Before that theorem, I need to explain you something else. First of all, you need to know what is a quadrilateral. Quadrilateral is what? Now, normally, rectangle, square, trapezium, parallelogram, those all are quadrilateral because it has four sides. Now, for example, if you have like this kind of shape, right? Any shape doesn't matter. Anyhow, it has a four side. It has four sides. Then we can call as quadrilateral. But cyclic quadrature mean when you have like this, inside the circle you have a four side shape like this. Now this is a cyclic quadrature, but some situation you need to understand very carefully. We have cyclic quadrature. It look like cyclic quadrature but not. Now for example like this, I think here is the center. Now sometime you may have this kind of four four side thing, but this is not a cyclic quadrature. Because why? Here these vertices, now here one vertices, here one vertices, here one vertices, here last one. So this in this shape, in this diagram, these three vertices on the circle, but this vertex, this corner, this vertex, not on the circle. It is center of the circle. So that's why this is not a cyclic quadrature. That means if you have a cyclic quadrature, first of all checking whether it's really cyclic quadrature. That means this all four corners, four vertices must be on the circle. Then you can call this as a cyclic quadrature, right? Otherwise it's not a cyclic quadrature, right? Then now regarding cyclic quadrature, again you need to know this thing, what the opposite angle. Now opposite angle mean like this. Now think this angle make by these two side, no? So now think if you have another shape, another cyclic quadrature like this, now you will have problem sometime whether this and this opposite angle. No, because why? Now to make this angle you use this side, no, this side and this side, or we can call as arm of this angle, and same arm, same side used for this angle also to make this angle. So that's why never will be this type of angles are opposite. So here opposite angle, this with this opposite, right? Remember, because if these two not opposite, that means this with this, no, right? Not this and then this. This also can't be like that. So this and this opposite angle. Try to understand at least that way. When you have problem, check. Now if you think this and this opposite, check whether both angle has common arm. Then it's not the opposite angle. This and this opposite, right? That's a method to understand which one is the opposite. If you have problem, but here very simple, direct. You can see this is opposite. Sometime you will have like very different to very different way the quadrilateral, right? Like this. Then sometime you can't understand whether this with which one is the opposite, with this which one is the opposite. So try to understand again here. This arm used for this angle, so this angle never, or this angle never will be this and this opposite, right? Like that. So here theorem is when you have a cyclic quadrature, opposite angles are, very carefully think, not opposite angle equal. Opposite angle are we normally call opposite angle are supplementary. That means when you add this two angle will be 180. Now for example, think if you thought here x, here y, as x plus y must be 180. Normally we call opposite angle are supplementary. That means when you add this opposite angle must be make 100 and add up to 180. That means if this 100, this should be 80. Like that. here 60, then this should be 120. It's like that. When you add these two angles, should be 180. That's the here theorem. Opposite angle in a cyclic quadrilateral, opposite angle must be must be supplementary. That means opposite angle add up to 180, right? Okay. Next theorem is little easy one. Now you know very well now what is the cyclic quadrature, right? Now next theorem is when you have a cyclic quadrature, right? Normally we call exterior angle of a cyclic quadrilateral is equal to interior opposite angle. So now that means this is a cyclic quadrilateral. As I told you, you need to understand, you have to check whether this is cyclic quadrilateral, otherwise it will not apply. So this is a cyclic quadrilateral. In this cyclic quadrature, I will extend it this side. I will extend it this side. Now, very carefully think, think this angle, this curve line with the curve line and this line. This is the angle. No, this is not the exterior angle. This is not even angle, right? Angle means from here to here. This is not a straight line. No, this is a curve. So this one and this one, this angle is equal to interior opposite angle. That means now this is the exterior angle of this angle. This is the interior angle. Interior, not the interior angle, opposite of that. That means this angle. These two is equal. Now think, if this is x, this must be x, right? This angle must be x. That means here 50, here also 50, here 30, here also 30, right? Very simple theorem here. When you have a cyclic quadrature, if you extended one side, this exterior angle will be equal to interior opposite angle, right? These two is equal. These two are equal. So if I write here y, then x equal y. You can write directly like that, right? Okay, now think this side, if you extend it, right? I mean this one, same cyclic quadrature, I will extend this side, right? Like this. Now here, this is the exterior angle, no? This is the exterior angle. This exterior angle will be equal to, this is the interior one, this is this angle, right? That means now think here, m, this is n, right? That means m equal to n. M equal n. It's like that. If you extended any side, doesn't matter. Exterior angle will be equal to interior opposite angle. Okay, another theorem regarding circle is we call normally alternate segment theorem. Alternate segment theorem. That means first of all you need to know what is the tangent mean of a circle. Tangent. That means now in this circle, if you choose one point here, through that point you can make a exact, through this point it must go right like this. Okay, I will make first of all, right? Now this is a tangent, but if you make like this, it's not a tangent. I mean like this way, because it not touch the circle. If you make again like this way, this also not tangent. This also these are not tangent, because why not not tangent? Tangent. This also not tangent, because this is outside the circle, this is inside the circle. These are not tangent. It must be exact one point, and then through that point it go, right? That's the idea of a tangent, right? Now the theorem is like this. Now think, if you have a tangent here for this circle, I think this way, this is the tangent. If you have here tangent and this tangent point here, think exactly the tangent point. From you do, if you have a chord inside the circle, a chord make with this tangent point. That means here is the tangent point. From this tangent point it go like this way. This is a chord, right? We call chord now when you have a circle. If you join two place, 2 point on the circle, that means it's a chord, right? Now one point is the tangent point, right? it must be like that. And then if you make a, if you normally we call subtended angle at circumference from this by this chord, it like this, you know, like this, like this. Now this angle and this angle equal, right? Try to understand this tangent line and the that chord, you know, exactly that make with the tangent point. Now this chord, now this angle equal to this angle. Now that means here x, here also will be x, right? Try to understand that. And not only that, now here at this tangent point we have another chord, now this one, so that's why this also equal. Now think here y, that means here also y. Here basic idea, when you have a tangent, at tangent point if you make a chord, by that chord, this chord, if subtended like this, you know, if go like this way, go this way, from this tangent point it's go like this way, this angle equal to this one, right? This tangent with that chord you have angle, that angle equal to this chord, like this way it go to here for this angle, right? Try to understand this chord, right? This chord, this is the little, you know, difficult one to understand in circle theorem, that's why I try to explain. Now this is the chord, this chord, and this is the tangent. Between that you have this angle, and that angle equal to, right, like this chord subtended angle, this one, right? This and this equal. And also if you have this side, this is another chord, no, to the tangent point, so that's why this angle equal to, now this is the chord, other next other chord, by that other chord subtended angle is this, so this equal to this, right? Try to understand that. That's a very important one because it's difficult for most of